Okay, so the next part of this lecture is complex number 1.2. So there are three learning outcomes. So we want to represent the complex number in Cartesian form, define the equality of two complex number, and show conjugate of complex number. Okay, so complex number. So certain questions does not have real roots. So you may have encountered this before, but your teacher will said that we have no real roots. Okay, so this is what we call as no real roots. So example, x squared plus 1 equal to 0. So this is a quadratic equation, and when we want to solve this question, what we get is x equal to plus minus square root of -1. So this one is not a real number. So by taking square root of -1 equal to I, so we can say that the solution is x equal to I or x equal to -I. So this imaginary unit I helps to solve equation with no real roots. Okay, the imaginary unit I. So we can express the square root of any negative number as a real multiple of I. For example, square root of -16. So this is actually equal to square root of -1 multiplied by 16. So by using the root of indices, we can separate this square root of -1 multiplied with square root of 16, which is equal to 4. So it's actually square root of -1 is equal to I. So I multiplied by 4, so we get 4I. Okay, and then this I also, if we have multiple of powers, we can simplify it as I squared equal to -1, I to the power of 3 equal to I squared multiplied with I, which is I squared equal to -1, so -I. And then I to the power of 4 is equal to I squared to the power of 2, so which is I squared equal to -1 squared, we get 1 as I to the power of 4. So complex number in Cartesian form. So we can represent complex number in Cartesian form, which is z complex number equal to x plus yi. So we have two parts here, the real part and imaginary part. So for example, we have z equal to 2 plus 3i. So this one is the real part. This one, 3i, is the imaginary part. The same as z equal to 5 minus 2i. So the real is 5, imaginary is -2. Equality of two complex. For example, we have z1 and z2, and it said that those two complex number are equal. So we can compare the real part of z1 equal to the real part of z2, and imaginary part of z1 equal to imaginary part of z2. So for example, if we have m plus ni, this is one complex number is equivalent to 3 plus 2i. So this is another one complex number. Means that the real part of these two complex number is equal. So we can say that m equal to 3 and n equal to 2. Okay, so for part so let's do example 4 for part A. So we have a plus b equal to 6. This is the real part. A plus b and 6, and a minus b equal to 4. This is the imaginary part. So we have these two equations. The first equation, the second equation. So we can do a operation of equation 1 minus equation 2. So what we will have is 2b equal to 2. So a minus a, b minus -b, so we get 2b. 6 minus 4 is 2. So finally we get the value of b, which is equal to 1. To find the value of a, we just need to substitute in any of the equations. So substitute b equal to 1 into equation 2. We have a equal to 4 plus 1, which is equal to 5. Okay, for question B, So we have a plus 2b equal to 9 for the real part. So this is the first equation, and then a minus b equal to 0 for the second equation. So to solve these two equations, we use simultaneous solve. So 1 minus 2, equation 1 minus 2, so we get a minus a 0, so we have 2b minus negative b, which is equal to 3b equal to 9. So b equal to 3, and then we can solve for a. So substitute b equal to 3 into 2, we get a equal to b, which is equal to a equal to 3. Okay, algebraic operation on two complex number. So we have addition, subtraction, multiplication. So this is the same as the polynomial. So we just need to replace I squared equal to negative 1. So let's do some example. Given that z equal to 4 plus 3i and w equal to 7 plus 5i. Find z plus w. So we just need to add the real number with the real number, imaginary number with the imaginary number. So we have 4 plus 3i plus 7 plus 5i. So 4 plus 7, this is the real part. So 4 plus 7 is equal to 11. And then for the imaginary part, 3i plus 5i is equal to 8i. So for question B, multiplication. So ZW. So Z is 4 plus 3i multiplied with 7 plus 5i. So you just need to expand as usual. So what we will have is 4 multiplied by 7, 3i multiplied by 7, 4 multiplied with 5i, 3i multiplied with 5i. So I give you the answer here. You should try on your own. Okay, so conjugate of complex number. So let's say if a plus bi is the conjugate of a minus bi. The same as a minus bi is the conjugate of a plus bi. What you notice the difference here? So this a plus bi is conjugate of a minus bi because we have the opposite or different notation for the sign for the imaginary, the same as the second one. Okay, so we change the sign of imaginary part. For example, 4 minus 3i is the conjugate for 4 plus 3i. Negative 2 plus 5i is the conjugate of negative 2 of minus 5i. So conjugate of a complex number we represent as z is denoted by z bar. So multiplication of conjugate of complex number give a real number. Means that if we multiply z with z bar, we will have a real number. So let's say a plus b is a complex number and a minus b is its conjugate. So we multiply these two, we will get a squared plus abi minus abi minus b squared I squared. So we can cancel out the abi, these two abi. So what we will have as the result is a squared plus b squared, where both are real numbers. So division of a complex number. So both numerator and denominator are multiplied by the conjugate of the denominator. Okay, so that is how we solve the division of complex number. Let's do example. So we want to simplify the expression. So for question A, so how to simplify this question? So what we need to do? We have to multiply with the conjugate of the denominator. So what is the conjugate of the denominator? 1 minus I. Multiply the denominator, we have to multiply the numerator. So what we have of the numerator? We have 3 minus 3i divided by 2. So the answer is 3 over 2 minus 3 over 2i. So you just need to expand as usual. For question B also, For 4 plus 7i divided with 2 plus 5i, we need to multiply with the conjugate of the denominator, which is 2 minus 5i. So expand everything and solve it. So you will get the answer. So the answer is 43 over 29 minus 6 over 29i. Okay, let's do example 7. Or not. Okay, so I just give you the answer for this example. Can you try on your own? So the answer here is 6 over 5 minus 8 over 5i. Okay, good luck everyone. Thank you.